Hey everyone, welcome back to another Logs.io training session. Today we're going to be talking about the 4 types of metrics as a kickoff to our metric series. Now, the reason it is important to start with this foundational knowledge is because it makes querying, building dashboards, and alerting a lot more intuitive. Now, before we jump into the 4 types of metrics, it's good to know that Logs.io is built on M3DB, which is a time series compatible database with Prometheus. And we utilize Grafana to be able to query, visualize, alert on, and explore all of your metrics. So with that in mind, let's jump right in. Now the first type of metric we're going to be talking about is a counter. So let's talk about what a counter is and what a counter is not. Counters can best be described as a metric that represents an increase whose value can only increase or be reset to 0 on a restart. This is a metric such as the number of tasks completed, right? Because that's always going to be increasing, but let's say we restarted the number of tasks, it would drop down to 0, which is okay. Now, what a counter is not is a value that can decrease or increase consistently or arbitrarily over time, such as the number of processes. For example, if your metric went from 7 down to 3, up to 5, down to 2, that would fall under a gauge metric, which we will talk about. The actual value of a counter, though, is not very useful at face value. A counter value requires calculation to compute the rate of change over time, or maybe a sum between 2 timestamps or a delta between 2 timestamps. Now, counters offer functions to us that allow us to compute these values and pull meaningful data out of the counter, such as rate, irate, increase, and delta. Now, I'm going to create a further video on the rate function because it truly is one of the best things about Prometheus. Now, for example, if we were taking the rate of x over 1 minute, what that's really doing is calculating the difference in value over 1 minute divided by 1 minute. So, let's say we had a scrape interval of 15 seconds. So 15, 30, 45, 60, that equals 1 minute, 4 data points. Now, what rate does is it will say, what is the difference in value over those 4 data points, which is stretched over that minute? Now, irate does something a little bit differently, where it takes the first data point and the last data point and makes an intuition. However, rate is a lot smarter than that because what it can do is it can handle counter resets and then make intuitions based on that, which we'll talk about in a future session. But it's important to note that counter metrics have their own functions that are accessible to us. Now moving on, we get into gauges. Gauge metrics are used for measurements that consistently increase or decrease arbitrarily. So, for example, if we're measuring CPU, memory usage, or maybe even the size of a queue, these all fall into gauges because they can go up and down at any given time, right? And that's not what a counter does. A counter is consistently increasing. Now, the value of a gauge metric can be meaningful without any additional calculation like or unlike a counter. Like I said, counters are often used to describe a rate of change over time. They're used to calculate a delta between 2 timestamps. Gauges are not usually done like this. However, you can use rate, delta, increase, and irate functions for gauges. It just doesn't make sense to, because the value is not consistently increasing and it can lead to problems. We will cover that in the rate episode, and I will show you why it's bad to use rate for gauges. So our best bet to calculate gauges is use averages, percentiles, max, or min over time. So let's look at an example of computing the average of memory on my production server in the last 10 minutes. You can see up above that what I'm using is average over time, which is calculating the average over a certain period of time, which is my range vector of 10 minutes. Now this is extremely useful because it's doing something similar to rate. However, it fits in with a gauge metric and can handle the ups and downs that it consistently goes through. So now that we've talked about gauges, we can move to histograms. Histogram metrics are used to represent a distribution of measurements. They're often used to measure request durations or the size of a response. Histograms split these metrics into a set of interval-named buckets and count how many measurements fall into each bucket. So you'll see suffixes within that histogram metric that has an underscore of sum, or an underscore of count, and then an underscore of bucket. So if you look up, you'll see all of these metric types within a histogram. We'll get underscore sum, underscore count, and then you'll have buckets with a upper bound. So if the metric value falls under that upper bound metric, meaning 0.01, for example, is our upper bound, that value is going to fall under that. If we have the upper bound or LE of 1, it's going to fall within that bucket. Now, histograms still allow you to calculate sum, count, and utilize functions like histogram quantile. So you can actually calculate the quantiles over time for a specific bucket. Summaries, moving on, are just a little bit different than histograms. They're very similar. However, what they do is they break up the metric into buckets. They use quantile values. So if we look at what a summary metric looks like, you can see that we still get the underscore sum and underscore count. However, we now get quantile labels instead of that LE upper bound. So if the metric value falls into a specific quantile, which is consistently calculated, then we're saying this falls under this quantile, throw it under that bucket, or throw it under that quantile. So we can still use similar function types as we use in histograms. We can still use rate because a lot of these metrics are counters. So we can also use gauge function types, but essentially they're aggregated views. So now that we know the 4 types of metrics, we can move on to the rate function and a little bit of Prometheus querying, which we'll cover in the next session. If you have any questions, as always, reach out to Logs.io support, and I'll link down a couple of resources that are very useful in terms of what these metric types do, as well as some Prometheus functions that you can use on these metrics, and then any other resources I find useful. Everyone have a great day, and I'll see you in the next session.